All right, so these are going to be the notes for linear inequality word problems. So this is for our systems of linear inequalities. First, let's go over the words and possible words that could mean less. So this is less than, greater than. I think of this because of less than, greater than, less than equal to, and greater than or equal to. All right, so I have a list of words here, and I'm going to be placing them down. So let's start with this word more than. So more than is going to be greater than. That looks like move, but it's actually more. All right, so we've done that one. Less than, that's pretty obvious. Less than. We have at least. At least is greater than or equal to. So the lowest you can have is that one, but you can have more. For the next one, at most means you can have the highest, but you can't go higher than that, so it has to go lower. So this one would be at most. Greater than or equal to and less than or equal to, I think we can figure out where those go pretty easily. So this is less than or equal to. And this one over here is greater than or equal to. All right, no more than. So no more than means you can have that much, but you can't have over that much. So no more than would be less than or equal to. And then no less than means that's the minimum you can have, but you can have more. So that would be greater than or equal to. We have greater than. Minimum. Minimum is like the lowest that you can receive. So it would be greater than or equal to. And last we have maximum. Maximum is going to be less than or equal to, because it's like in a class, the highest grade you can get is 100. You can't get over that, but you can get less than that. So that's less than or equal to. So that's just a list of words that definitely helps us with working out word problems. All right, so some of the steps we can use to writing and graphing systems of inequalities. Same as before, we identify and define the variables. Then you're going to write the system of inequalities. And if they happen to be in standard form, you want to blank the system of inequalities in slope-intercept form. So you want to write them or rewrite them in the system of inequalities in slope-intercept form. Then you want to graph the system of inequalities. And the intersection of the half planes are the solutions of the inequalities. Now, since these are word problems, we have to make sure that the solutions we come up with do make sense. All right, so let's go ahead and take a look at two problems here. So it says, write a system of inequalities, graph the system, and list two possible solutions that would be true for the system. So that's where that reasonableness comes in. Like, does it make sense in the situation? So for me, you'll always see me use X and Y. So it says Linda works at a pharmacy for $15 an hour. She also babysits for $10 an hour. Linda needs to earn at least $100 per week, but she does not want to work more than 20 hours per week. So we have X and we have Y. So the things we're talking about here are Linda working at a pharmacy and Linda babysitting. So I'm going to say that X is the number of hours as a pharmacist. or works, number of hours worked at the pharmacy, and Y would be the number of hours babysitting. Okay, so let's take a look at these equations here. So the first one, Linda works at a pharmacy for $15 an hour. That deals with money. She also babysits for $10 an hour. That deals with money. Linda needs to earn at least $100. So if we go back over here, we see that at least is greater than or equal to. So at least greater than or equal to $100 per week. So here she gets $15 for every hour she works as a pharmacist, plus $10 for every hour she works as a babysitter, and Linda needs to earn at least, so greater than or equal to, $100 per week. But she does not want to work more than 20 hours per week. So she wants to work so many hours in the pharmacy. She wants to work so many hours babysitting, but she does not want to work more than 20 hours per week. So that is going to be less than 20. So does not want to work more than. Okay. So from here, we are going to graph these. Now, before we actually graph them, you do have to put them in slope-intercept form. So for this one here, I'm going to do this one in blue. All right, so first I'm going to subtract 15x from both sides. So we have 10y is greater than or equal to negative 15x plus 100. Then we're going to divide everything by 10 to isolate the y. And y is now greater than or equal to 15 over 10. That's going to be negative 3 halves, because 5 goes into 15 3 times, 5 goes into 10 twice. And 100 divided by 10 is 10. So let's go ahead and graph that. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and my slope tells me to go down 3 and right 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then up 1, 2, 3, 1, 2. And we're just going to graph these here. And this is a solid line. And she wants to make more than, so we know it's going to be shaded above. All right, for the next one, it says, but she does not want to work more than 20 hours per week. So her hours combined need to be less than 20. So here, this one's a pretty easy one to solve. We are just going to subtract the x, and y is less than negative x plus 20. So we start at 20, so this was 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. My slope is down 1, right 1. And I'll just continue on this trend. And I'm going to make it dashed because it is less than, but she does not want to work more than. And that could be construed as no more than, so we could make that as an equal bar. So I'm going to do that actually because I think it makes more sense to be a solid line here. Yeah, there we go. All right, and from here, it's less than. So we shade all of this region here where they intersect. So now we know that our solution set is between these two lines. Now, from here, let's talk about unreasonable solutions. We can't pick anything to the left of this y-axis because this creates negative numbers and you cannot have negative hours. Just like we cannot choose any numbers below the x-axis because these would make negative numbers as well, or negative hours, and that's not possible. So when we pick any reasonable solution, so it asks us to list 2 possible solutions. So you can pick any point, so like right here. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So 8 comma 2. What that means is she can work 8 hours at the pharmacy and 2 hours babysitting, and she would satisfy. She would make more than $100, but she would work less than or equal to 20 hours in the week. So once again, you just pick any point inside here. Now decimals actually would make sense, but I like to keep whole numbers here, so just pick some random point right there as long as it's where the two lines intersect. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So once again, she works 6 hours at the pharmacy and 4 hours babysitting. She will make more than $100, but she'll work less than 20 hours. All right, and we have one more problem to go through here. This one says, Gloria is starting her own company making teddy bears. She has enough bear bodies to create at most 40 bears. Gloria charges $15 for girl bears and $12 for boy bears, and she wants to make at least $540 per week. So once again, we have X and Y. So she has enough bear bodies to create 40 bears. And so let's say X is the number of girl bears. And Y will be the number of boy bears. So Gloria is starting her own company making teddy bears. She has enough bear bodies to create at most 40 bears. Okay, so let's see. First equation. She has enough bear bodies to create at most 40 bears. So over here, once again, at most is less than or equal to. Well, she has so many girl bear bodies plus so many boy bear bodies, and she can make at most, which is less than or equal to, 40 bears total. For the next equation, she charges $15 for a girl bear, which is 15 times the number of bears, so 15 times X, plus $12 for boy bears, so 12 times Y, and she wants to make at least, which is greater than or equal to, $540. Okay, so the first equation looks easy to graph, to solve. So X plus Y is less than or equal to 40. We subtract the X, and Y is less than or equal to negative X plus 40. All right, and before I solve that one, I'm gonna go ahead and do the next one. So we have 15X plus 12Y is greater than or equal to 540. We are going to subtract the 15X from both sides. So 12Y is greater than or equal to negative 15X plus 540. We're going to divide every part by 12. So Y is greater than or equal to, negative 5 and 12 are both divisible by 3. 3 goes into 15 5 times, so that's negative 5 over 3 goes into 12 4 times, X plus, and now we have to figure out how many times 12 goes into 540, which is going to be 445. Okay, so I have 45 here. So these are the two equations. Now, obviously, this is not going to fit on this paper here, so I'm going to actually change the scales a little bit. So you can go by twos. If we go by twos, we know there's 18 spaces, which is 36. So I'll probably just go by 5. So this would be like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And this will also go by 5s. I'm going to keep it consistent for myself. So 20, 25, 30, 35. So 5, 10, 15, 20, 25, 30, 35, 40. Let's see if we can fit it on there. So for this blue line, we start at 40. So right here. And my slope is negative 1 over 1. So if I were to go down 5 and right 5, 5 divided by 5 is 1. So that's actually going down 1, right 1. So down 5, right 5, down 5, right 5, down 5, right 5. And I just keep going that pattern, down 5, right 5. All right, and then up 5, left 5. Solid line. And it is less than or equal to, so I would shade below. And for my next one, we start at 45, which is right above it. and we go down 5, so I'm going to go down 5, 10, 15, 20, 25, and over 4. 5, 10, 15, 20. So if I go down 5, that's 25, and if I go right 4, that's 20. So if you were to reduce those two, it would be 5 over 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. And solid line. Solid line. 1, 2, 3, 4, 5. And there. Okay. And this one right here is greater than or equal to. So the only parts where it intersects with a greater than or equal to is actually going to be in this small little area right here. And once again, I cannot use these values because they go below the x-axis, but I can use any value that falls inside of here. So I see a nice point right here, which is 5, 10, 15, 20, 25, 30, and 5. And then I can use this point here since it's a solid line. I can go 5, 10, 15, 20, 25, 30, 35, 40, and 0. So what this says, if I make 30 girl bears and 5 boy bears, that'll be less than or equal to 40, but I will make more than $540 or equal to it. And if I were just to make 40 girl bears and no boy bears, I would still have less than or equal to 40, but I would make greater than or equal to 540.